Hello students, welcome back to lesson 13, the graph of a linear equation in two variables. So we saw before, we had some graphs going up and down. They were all points in a straight line, but we're going to see if everything in between those lines also works on our equations. Okay. So sometimes they didn't, like when we did the number of basketball shots, the 2-pointers and 3-pointers, it couldn't be numbers in between. It had to only be those exact dots. But here we're going to see if equations that work in between those dots. So we predict the shape of a graph of a linear equation. You should be able to predict that now. Linear equation. By finding and plotting solutions on a coordinate plane, we informally explain why the graph of a linear equation is not curved or why it's straight according to the solutions. All right. So one way to determine if a given point on a graph is a linear equation is by checking to see if the solution to the equation, not all graphs of linear equations are lines. We just saw that some of them are individual points. So let's discuss. In the last lesson, we saw the solution of a linear equation in two variables can be plotted on a coordinate plane as points. The collection of all points x and y in a coordinate plane such that each xy ordinate point is a solution is called a graph of ax plus by equals c, or a graph of our linear equation. So how many possible solutions for an equation are there? What would it look like if we plotted every possible ordered pair on a solution? Right? So again, going back to that basketball one, there was only so many different possible ways you can shoot a 2-pointer and a 3-pointer and get 32 points in the game. Okay. For most linear equations, it's going to be different. So let's take the example of x plus y equals 6. So if I graph it out, if I choose 0, 1, 2, 3, 4 for my x, because those are the simplest numbers, then my y is going to be 6, 5, 4, 3, 2, right? If this is 0, then I have y equals 6. If this is 1, subtract 1 from both sides, y equals 5. If this is 2, subtract 2 from both sides, y equals 4. Go on from there. So if I graph it, the graph looks like this. There's my dots. They're going in a straight line. We know it's linear. But this is not the basketball problem. This is just x's and y's. So can I get dots in between these dots? So if I put in between these dots, would my graph be all wonky like this? Or would it be a straight line? So let's try some in-between stuff. So instead of 1, I pick a half. Instead of 2, I pick 1.5. Instead of 3, I pick 2.5, etc. So here were my original points, 0, 1, 2, 3, 4, 5. And here are my half points, a half, 1.5, 2.5, 3.5. So they put up like this. So my original points were 0, 6, and 1, 5, and 2, 4, and 3, 3, 4, 2. All right, and then I've got the halfway points. So this is a half and 5.5, right? Because 1/2 plus 5.5 equals 6. And this is 1.5, and this is 4.5. Because 1.5 plus 4.5 equals 5, equals 6, etc., etc. So this is 2.5 and 3.5, and this is 3.5 and 2.5, and this is 4.5 plus 1.5, etc. So all of the points in between, and you can still see they look like they're going in a straight line still. So what goes on next? What happens if I put the equation into a calculator? This is what comes out. a straight line. They don't give us any points on this line. They just tell us it's a straight line because anything on this line works. If I pick 6 for my x, then I get 0. That would be this point right here. If I 6 for my x, then I get 0 for my y. That's this point. If I pick 0 for my x, then I get 6 for my y. Okay. But if I pick -1, then I get -7. Okay. -7. If I pick 3, 3, I get 3, 3. Okay. So, and anything in between. If I pick the half, I get the half points too. Where does this line start and where does it end? Is there an end to this line? Can I pick any number for x? If I picked 15 for x, is there a point way down here somewhere? Is there a point on the line way down here? Yeah. Okay. So try these equations and tell me what the graphs look like. So if you want to try these equations, go to desmos.com/calculator and just type in exactly as you see this. Y equals x minus 6. Y equals 6 minus x. 3x plus y equals 12. And you can do this one. 2x, you use the caret, the key above the 6 for the exponent. So you would write 2x caret 6, 2 plus y equals 10. Okay? And this would be the caret y, etc., caret 3. So put those in, see which ones are linear and which ones are not linear. Okay? And now I would like you to, which table are the points on the graph 2x plus y equals 7? So let's try it. If I put a 0 in for x, 2 times 0 is 0, y equals 7. So if I put a 0 in for x, then my y has to equal 7. And so that would not be this one. But this one would be good. This one would be good. That would not be this one. So now I've crossed out A and D. If I put a 1 in for x, 2 times 1 equals plus y equals 7. So that would be 2 plus y equals 7. Subtract 2 on both sides. Y would equal 5. And that's this one. So I cross out this one. So C is the only one that works. And I only had to try out 2 numbers. All right, homework. Go ahead and get to work, and let's get on to lesson 14. Lesson 13, a graph of linear equations in 2 variables. So we learned last time that we could graph, and now this time we learn we can predict the shape of a graph of a linear equation, which will be a straight line, by finding and plotting the solutions on a coordinate plane. Students, informally explain why the graph of a linear equation is not curved. So it's straight because it has a constant, and that constant we sometimes call the slope. Okay, that's the shape of a graph, is a straight line that rises or falls depending on the constant, which is known as the slope. And one way to determine if a given point on a graph of a linear equation is by checking to see if the solution to the equation. Note that all graphs of linear equations will appear to be lines. So if you want to know if a point is on a line, you substitute x and y into the equation, and if it's true, then that's the solution.